Hey guys, so I've had a couple of questions about going over the conservation of energy at National 5 level. So what we're going to do first is we're just going to have a brief talk about the different types of energy we have. Okay, and I have a simple way of remembering it. So let me introduce you to Professor Shackle. So the first letter of each one of these represents a different type of energy. And the easiest way to remember it is just to remember Professor Shackle. And P stands for potential. Then we have sound, heat. Now this one is because back in the day when I learned physics it was atomic, but we now call that nuclear. Then we have chemical, kinetic, light, and electrical. Okay, so we have 8 different types of energy, and these are really useful for us. But what we're trying to look at today is the conservation of energy. So one of our main laws in physics, the law of conservation of energy, which has also been adopted into thermodynamics and is part of the first law of thermodynamics, is that energy cannot be created or destroyed. Okay, it can only be changed from one form to another. So I'll say that again, energy cannot be created or destroyed it can only be changed from one form to another. Okay, and so the way we can look at this is if we're dealing with a question containing something that's using energy, we can look at where the energy is going or where the energy might be going, and where we're losing energy to. Okay, so let's to start with, one of the most common ways that National 5 are going to assess you on this is to look at the conservation of between kinetic and potential energy. Okay, so let's assume we have a ball, right, and that ball is raised up at a height we're going to call h, funnily enough. So at that height of the ball up, we know that the ball will have potential energy because that's due to the gravitational potential energy it gets. Okay, so it has gravitational potential energy at the top. However, if we were to drop that ball, its height would decrease, and so the amount of gravitational potential energy it would have would decrease. But that energy has to go somewhere, because I've just said that the law says that energy cannot be created or destroyed. So if that's the case, where is it going? Well, what is the ball doing now? The ball's not stationary. The ball's moving. So what type of energy is our energy of movement? Well, that would be the kinetic energy of the ball. Okay? And so what we can see is the ball will have all gravitational potential at the top, and as it falls, its gravitational potential will go down, but its kinetic energy will increase. Now, in physics, we tend to assume that there's no energy lost to friction in this sort of instance, so we're going to assume that there's only these two energies involved, okay? Which means that immediately before the ball hits the ground, all of the potential energy will have changed into kinetic energy. All of it. So, in that case, our potential energy at the top will be equal to the kinetic energy at the bottom. Now this leads us into a lovely little equation that we were able to derive, and it's the first experience that National 5 physicists have of proper deriving an equation like this. So follow with me and see if you like it as much as I do. So EP is mgh and EK is equal to a half mv squared. Okay, so if we start to rearrange this, because we want to work out the velocity of the ball right before it hits the ground, okay? We know that it was up a height h, but that's all we know about it right now. In that case, we can work out that if the ball is going to have the same mass at both, that's going to cancel off. Okay, And if something is a half on one side and bring it over to the other side, it'll become 2. So we will have 2GH is equal to V squared. And then basically, to get rid of the squared, you have to square root the other side. And I'm going to swap them around so that it looks nicer. And we're going to have V is equal to the square root of 2GH. Now this is the same for all objects that fall, and convert all their gravitational potential energy into kinetic energy. I hope this quick introduction to this was helpful. I know that some of you had said it was something you were struggling with, so hopefully it's given you a wee insight into the conservation of energy law.